Section 2 of the Science History of the Universe, Volume 2. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information, or to volunteer, please visit LibriVox.org. Recording by Eric Metzler, Albuquerque, USA. The Science History of the Universe, Volume 2, edited by Francis Rolt Wheeler. Geology. Chapter 1. The Ancient Cosmogonies. Part 2. The work of Aristotle, 384 to 322 B.C., marks the culminating point reached by the Greeks, both in the domain of speculative philosophy and in that of empirical observation. His treatises furnish an admirable exposition of the state of natural knowledge in his time. When he wrote, the geocentric view of the universe was still publicly accepted without question. But he had firmly grasped certain truths regarding the globe, which, though taught long ago by some of his predecessors, were not yet generally admitted. Accepting the common belief that the world consisted of four elements, he looked on these as arranged according to their relative densities. He said, "The water is spread as an envelope round the earth. In the same way above the water lies the sphere of air, while outside of all comes the sphere of fire." With regard to the surface of the planet, Aristotle had formed some sagacious conclusions, though mingled with certain of the misconceptions that were prevalent in his time. He remarks that earthquakes are due to a commingling of moist and dry within the earth. Of itself the earth is dry, but from rain it acquires much internal humidity. Hence, when it is warmed by the sun and by the internal heat, wind is produced both within and without its mass. Wind, being the lightest and the most rapidly moving body, is the cause of motion in other bodies, and fire united with wind becomes flame which is endowed with great rapidity of motion. It is neither water nor earth which causes an earthquake. It is the wind, when what is vaporized outside returns into the interior. Aristotle regarded earthquakes and volcanic eruptions as closely related phenomena. He states that it had been observed in some places that an earthquake has continued until the wind from the interior has rushed out with violence to the surface, as had then recently happened at Heraclea on the Euxine, and before that event at Hiera volcano, one of the Lipari Isles. At this latter locality the ground rose up with a great noise, and formed a hill that broke up and allowed much wind to escape from the fissures, together with sparks and cinders which buried the whole of the neighboring town of the Liparans. The shock was even felt in some of the towns on the opposite mainland of Italy. Aristotle was further led to propose an explanation of the great heat that forms part of the volcanic phenomena. The fire within the earth can only be due to the air becoming inflamed by the shock, when it is violently separated into the minutest fragments. What takes place in the Lipari Isles affords an additional proof that the winds circulate underneath the earth. This idea that volcanic action was mainly due to the movement of wind imprisoned within the earth obtained wide credence in antiquity. Aeolus, the god of the winds, was believed to have his abode under the so-called Aeolian Isles, which are all of volcanic origin, and among which eruptions have been taking place since before the dawn of history. This tireless observer of antiquity also discusses the phenomena presented by rivers, and shows considerable acquaintance with the drainage system on the north side of the Mediterranean basin. He criticizes previously expressed opinions as to the source of rivers, particularly ridiculing the suggestion of Plato that all rivers flow directly from a vast mass of water under the earth. He appears to have held the opinion that just as the vaporized moisture in the atmosphere is condensed by cold and falls in drops of rain, so the moisture beneath the earth is similarly condensed and forms the sources of rivers. He states that the mountains, by their cold temperature, condense the atmospheric moisture and receive a vast quantity of water, so that they may be compared to an enormous suspended sponge. He shows by geographical illustrations, drawn from Asia and the Mediterranean basin, that the largest rivers descend from the loftiest ground, where the water accumulates in numberless channels. He admits the possible existence of underground lakes from which rivers may issue, and alludes to the disappearance of some streams into subterranean channels. No writer of antiquity has expressed himself more philosophically than Aristotle regarding the past vicissitudes of the earth's surface. Having studied so carefully the operations of the various agents that are now modifying that surface, he recognized how greatly the aspect of the land must have been transformed in the course of ages. His remarks on this subject have a strikingly modern tone. He contemplates the alternations of land and sea and furnishes illustrations of them, much as a geologist of today might do. The sea now covers tracts that were formerly dry land, and land will one day reappear where we now find sea. These phenomena escape our notice because they take place successively during periods of time which, in comparison of our brief existence, are immensely protracted. Whole nations may disappear without any recollection being preserved of the great terrestrial changes which they have witnessed from beginning to end. The deluge of Deucalion, Aristotle suggests, affected Greece only, and principally the part called Hellas, and it arose from great inundations of rivers during a rainy winter. But such extraordinary winters, though after a certain period they return, do not always revisit the same places. He concludes with these remarkable words: "It is clear that, as time never stops and the universe is eternal, the Tanais and the Nile, like all other rivers, have not always flowed. The ground which they now water was once dry. But if rivers are born and perish, and if the same parts of the land are not always covered with water, the sea must undergo similar changes, abandoning some places and returning to others, so that the same regions do not remain always sea or always land, but all change their condition in the course of time." The great advances along certain lines of thought under the impetus of the Roman leadership infused a more realistic spirit into the investigations of all great workers in natural science, especially those interested in geology. Among the latter the first place must be given to the historian and traveler Strabo, circa 63 B.C., whose geography, comprising 17 volumes, was written about the beginning of the reign of Tiberius. It contains not a few important facts in regard to the general effects of subterranean energy. Thus he cites a number of earthquakes by which chasms in the ground were formed. Thousands of people were destroyed and cities were swallowed up. He also gives some information regarding volcanic eruptions which had taken place within the historical period in the Mediterranean region. In his time Mount Vesuvius was not only quiescent, but was not known ever to have been active. His quick eye, however, detected the true origin of the mountain. From the aspect of its summit he inferred that it was once a volcano, with live craters which had become extinct on the failure of the subterranean fuel, and he compared its slopes to the ground around Catania, where the ashes thrown out by Etna have formed an excellent soil for vines. He recognized the truly volcanic nature of the whole district from Etna to the Phlegraean fields, under which Typhon, as Pindar sang, lay crushed on his burning bed. In his excellent account of the ascent of Etna, Strabo compares the molten lava to a kind of black mud which, liquefied in the craters, is ejected from them and flows down the sides of the mountain, cooling and congealing in its descent, until it becomes a motionless dark rock like millstone. He also attributes earthquakes to the force of winds pent up within the earth. The doctrine that volcanoes are safety valves, therefore, which has been quoted as a modern idea, is prior in origin to the beginning of the present era. The oceanic islands far from any mainland have, according to Strabo, been thrown up by subterranean fires. In support of this view Strabo cited the case of a volcanic eruption in the year 196 B.C. between Thera and Therasia. For 4 days flames rose from the ocean, and as these died down it was observed that a new island had been formed, measuring 12 stadia in circumference. Strabo is therefore rightly regarded as the father of modern theories of mountain making. He pointed out that Sicily in his time was less frequently disturbed by earthquakes than it had been in previous ages, before volcanic discharges were known in the district; and he correlated the comparative tranquillity of the ground with the means of escape afforded for explosive underground vapors by the volcanic vents that had opened at Etna, in the Lipari Isles, and in Ischia. It speaks highly for Strabo's powers of observation that he should have recognized in Vesuvius a volcanic mountain, although it was then quiescent. Probably the most acute scientific observer of Roman times was Seneca, the physician of the Emperor Nero, 2 B.C. to 65 A.D. Quite recently Nering has placed the importance of the work of Seneca in its true light. The Quaestiones Naturales contain detailed communications about earthquakes, volcanoes, and the constructive and destructive agencies of water. Seneca explains earthquakes partly as a result of the expansion of gases accumulated in the earth, partly by the collapse of subterranean cavities. He appears to have been much impressed by the earthquake which did so much damage in Campania on February 5, 63 A.D., for he refers to it again and again, and furnishes from the lips of eyewitnesses some interesting particulars regarding it. Thus he tells how a flock of 600 sheep were killed in the district of Pompeii, a fate which he attributes to the rise of pestilential vapors from the ground. He was informed by a most learned and serious friend that when he was in the bath, the tiles on the floor were separated from each other and were then driven together again, while the water at one moment sank through the open joints of the pavement, and thereafter boiled up again and was jerked out. The philosopher's account is the earliest detailed description of an earthquake which has come down to us. Seneca regarded volcanic eruptions simply as an intensified form of the same series of phenomena, and volcanoes themselves as canals or vents between local subterrestrial reservoirs of molten material and the earth's surface. In speaking of two outbreaks at Santorin, he remarks that an island rose out of the sea by protracted eruptions from below, and he notes that the internal fire is neither extinguished by the weight of the superincumbent depth of sea nor prevented from rushing to a height of a couple of hundred paces above the water. He speaks of Etna having sometimes abounded in much fire and thrown out a great deal of burning sand, day being turned into night, to the terror of the population. On such occasions thunder and lightning are said to have abounded, but these came from the concourse of dry materials and not from ordinary clouds, of which probably there were none in such a raging heat of air, a shrewd anticipation of the modern distinction between ordinary atmospheric electric discharges and those evoked during the ejection of vapors, gases, dust, and stones from a volcanic orifice. The earth to him, however, was primitively a watery chaos, and it is more especially in his treatment of the action of water in dissolving and carrying away rock material, together with his explanation of the origin of sediments and deltas, that Seneca has shown his remarkable insight and sound judgment. His ideas on the origin of river water were no further advanced than those of his predecessors. He agreed with them in attributing all rivers to an inexhaustible internal source. Water being one of the four elements forms a fourth part of nature. Why then, he argued, should there be surprise if it can always keep pouring out? Just as in the human body there are veins which when ruptured send forth blood, so he thought in the earth there are veins of water which are found even in the driest places, at depths of 200 or 300 feet, and which when laid open issue in springs and rivers. The water at these depths, so far below the limits to which rain can moisten the earth, is not regarded by him of atmospheric origin, but living water, aqua viva. The learned historian, Pliny the Elder, 23 to 79 A.D., has handed down to us a compendium that embraces the whole scientific knowledge of antiquity. By a tragic decree of fate this untiring student and naturalist met his death while engaged in observing the grandest geological event of historical antiquity, the first outbreak of Vesuvius in the year 79 A.D. He died in the open field, probably suffocated by the volcanic vapor and ash. His corpse was found unharmed 3 days later, when the darkened sky finally became clear. The younger Pliny's vivid description of the eruption of Mount Vesuvius and the accompanying earthquake is one of the most remarkable literary productions in the domain of geology. Section 2. Recording by Eric Metzler, Albuquerque, USA, November 2015.